Bismillahirrahmanirrahim. Hi, dear students. It's our lecture 8. Today, we will be talking about waiting line models. So, queuing theory is a quantitative analysis of entities such as people, machines, data, waiting in lines for some kind of services. Just imagine or recall that last time you had to wait at a supermarket checkout counter, or you've been to a bank and you had to wait for your turn, or to be served at a fast food restaurant. So, in like there are many other waiting line situations. The time spent waiting is indeed undesirable. Um, Adding more checkout clerks, bank tellers, or server is not always the most economical strategy for improving services. So business need to identify other ways to keep waiting times within tolerable limits. Now, why we cannot hire other people, uh, or other servers or other clerks? Because you have to pay, and this is a cost. In addition, you have to provide them health insurance, maybe pension, may also space. So there are too many constraints. That's why you cannot just um, solve this problem by adding more staff to your workplace. To date, many models have been developed by the researchers to help managers in making better decisions concerning the operations of waiting line. So, in the management science terminology, a waiting line is also known as a queue, and the body of knowledge dealing with waiting lines is known as queuing theory. So, in early 1900, uh, a telephone engineer began a study of congestion and waiting times occurring in the completion of telephone calls. Since then, queuing theory has grown far more sophisticated with applications in wide variety of uh, waiting line situations. And in a while ago, I mentioned like there could be too many examples where we could deploy the concept or use the concept of queuing theory. Okay, waiting line models consist of mathematical formulas and relationships that can be used to determine the performance measures, or you can also call them operating characteristics of. So, operating characteristics include that what is the probability that no unit are in the system, the average number of units in the waiting line, the average number of units in the system, the average time a unit spends in a waiting line, uh, the average time a unit spent in the system, and the probability that an arriving unit has to wait for a service. So such performance can definitely help in decision making process, or in easier word you could say managers who have such information can basically aid them or help them in making decisions that will balance the desirable service level against the cost of providing the service. So it's like a balancing. um, Case in point, for example, if you have a bank, um, and you have an ATM machine, then the ATM waiting times at a specific bank can give you sensible information regarding or helping in determining how many number of ATMs do you need of your bank in that particular city. Um, in addition, a waiting line model can help a hospital um, to develop policies to improve response time for medical emergencies. So that's like the applications of waiting line model or queuing theory. Okay. Let's talk about basic queuing system. So let's say we have um, a restaurant. A server takes a customer's order, determines the total cost of the order, takes money from the customer, and then fills the order. Once the first customer order is filled, the service takes the order of the next customer waiting for the service. Such a kind This operation can be example of a single channel waiting line. Each customer entering like a food restaurant must pass through one channel, one order taking, and order filling. To place an order, pay bills, and receive the food. Right? When more customers arrive that can be served immediately, they form a waiting line and wait for order taking and order filling station to become available. So a single channel waiting diagram here is shown. You have customers entering, and they have like different customers waiting in a queue. They order. Once their order has been filled, so they just leave, and the attention is on the next customer. So here in this so this is basically my this queue. Here you can see a lot of customers waiting, so this can be my waiting line, and this is my server, or let's say a service facility. So order taking and order filling, it's done over here. Customer will leave after the order is filled. So that's how it works. So before I talk about distribution of arrivals, which should be probabilistic, um, so let's talk about this later. I would like to give few example of commercial service systems that are queuing systems. So you go to barber shop, that is type of system. Customers are people and server is a barber. Bank shop, bank teller services, people are customer, teller is basically a server here. And you can see other examples here. So example of internal service systems that are queuing systems. So you are waiting for um, to get copies of documents. So let's say type of system could be copying services, customers will be employees, and copy machine is basically my server. Once it is free, so you can always use it. Type of system, production system, customers are jobs and server is machine. Examples of transportation service systems that are queuing systems. So highway toll booth, customers we can consider that cars are basically your customers, and cashiers working in the tool booth are basically your servers. um, just taking a random example, let's say airline service. So people using that airline service are our customers, and airplane is basically my server.